In this video, we will talk about the other types of quadric surfaces. So far we've seen elliptic paraboloids and hyperboloids of two sheets. There are four other basic types of quadric surfaces. I'm briefly just going to sketch what these look like, but our method of using cross-sections will help us draw any one of these. Alright, so for elliptic cone, let me begin by drawing some axes. I'll draw my x, my y, and my z-axis, so negative directions. Let me do the same thing for the next one, just to get ready. So I'll draw my axes, so my y, x, y, and z, and the negative directions. And now let's draw in these shapes. So an elliptic cone looks like, I think, what we'd expect. It'll look like a cone. So I'll have something like this, cone-like. And the cross sections are going to be ellipses, but it also extends downwards. So there's like a singular point there where this sort of like upward cone and this downward cone sort of meet. And the downward cone's cross sections are also ellipses. And this elliptic cone, I've drawn it sort of being parallel to the z-axis. But it doesn't have to be. It could be parallel to the x-axis or the y-axis. And that just depends on the equation and what we get when we draw our cross sections. Alright, so the next type of quadric surface is an ellipsoid. So an ellipsoid is sort of a 3D version of an ellipse. So I'm going to draw sort of this ellipse shape. Ooh, when I need to draw my y-axis a little bit longer. So negative y-axis, make that longer. And the cross sections are going to be ellipses. So imagine that there's this cross section that's this ellipse, and another cross section that's an ellipse. So these cross sections I'm drawing just so happen to be parallel to the xz plane. Just draw one more of these. Another cross section that's an ellipse. So that's an ellipsoid. It's a 3D ellipse. And a sphere is a special type of an ellipsoid. Just like a circle is a special type of an ellipse. Alright, there are two more types of basic quadric surfaces. So we've talked about hyperboloid of two sheets. There's also a hyperboloid of one sheet. So for hyperboloid of one sheet, let's begin by drawing some axes. Let's keep the axes in black though. So I'll draw z, and an x, and a y, and the negative directions now. Let me do the same thing for this next one, just to get ready. So my x, my y, and my z, and then the negative directions. So for a hyperboloid of one sheet, that'll look something like the following. So it'll look something like, or I have a hyperbola. I'm just drawing this one on the YZ plane, and another hyperbola. And then the cross sections are going to be ellipses like this. Okay, so the cross sections are going to be ellipses like that. And then when I draw the cross sections on the xz plane, so when I look at, say, the x-intercept of this, in the x-intercept on that side, and I draw the cross sections on the xz plane, those are going to look like hyperbolas as well. So there's going to be a hyperbola. This one's sort of like in the front of my picture. And there's one in the back. This one's in the back. So I'm going to draw that with a dashed line just because it's in the back. And that's a hyperboloid of one sheet. Okay, so it's sort of this tube-like shape that sort of warps upward and warps downward. Okay, and the final shape is a hyperbolic paraboloid. So this is a combination of a parabola shape and a hyperbola shape. Okay, so this one's maybe the trickiest to draw. I'm actually going to draw the y-axis a little bit further in this direction. And I'm going to draw this with a parabola that has its vertex here at the origin. And this parabola, I'm just drawing it on the YZ plane. Okay, and then where the origin is, actually no, let me draw it like this. Where I've drawn these ends, so where I've drawn this end and this end, I'm going to draw a parabola sort of going downward. So parabola going downward here, parabola going downward there. I'm going to draw the same thing at this other end. I'm going to draw sort of a parabola going down this way, parabola going down the other way, and the other way it'll sort of go behind this other line, so I won't be able to see it for a bit. Okay, and then the bases of these sort of make a hyperbola shape, and the same thing with these other two bases. So this other base is going to make a hyperbola shape. So I'll be able to see it for a while, then it's going to go behind the sheet. It's going to go behind and behind and behind, and then that'll meet with this other part, which sort of goes behind it, and it's making this type of shape. And where the origin is, it makes another parabola going down this way, and in the back side, I'll draw it with a dashed line. It goes down that way. And of course, the shape doesn't stop here, like it would extend infinitely downward, infinitely downward, infinitely this way, infinitely down, infinitely out. But it sort of has this general shape. So one important point in this shape is this point right here, and that is called a saddle point. So right now, for our purposes, a saddle point is something that occurs here on these hyperbolic paraboloids. A saddle point kind of visually is what we sometimes have like at a mountain pass, or one way it's sort of like going upwards like this parabola sort of thing. But in the other direction, in this x direction, it's sort of paraboling down. So these saddle points are things that we will see more of in Math 14. Okay, so this is a bit of a preview to stuff that you'll see in more detail in Math 14, but we are going to get exposed to it here in our class as well, in the context of these hyperbolic paraboloids. Okay, so the thing that I care about the most is that you know how to draw these shapes if you have the equation given to you by using cross sections. So your book has a table where it draws all of these quadric surfaces, basic quadric surfaces shapes. So these four, as well as the two that we've talked about in the previous videos. And it describes the equation for each one and what the equation looks like. So I care the most that you understand how to graph them using our technique of using cross sections, because that emphasizes how well you understand this technique rather than how well you're able to just memorize what the graphs look like. All right, so we have done our last goal, which is talking about what the graphs of the other quadric surfaces look like. So we've made it to the end of 12.6, and we are happy about that. End of 12.6.